Hey everyone, good afternoon, and thank you for joining us. We're going to talk through our experiences building a conversational knowledge base, and if the demo gods allow us, show you a demo of what we just built. So my name is Tu. I'm a senior education engineer at HashiCorp, where I teach people how to use our products like Terraform, Consul, Nomad, and Vault.
And my name is Kerim Satirli. I'm a senior developer advocate at HashiCorp, the author of O'Reilly's Terraform Cookbook, and generally somebody who likes to play with robots. And that's pretty much how we got into this in the first place. So let's talk a little bit about the origins of why we needed a knowledge base in the first place. Quick show of hands, who here likes to code in their spare time? Beautiful, right? So you get this thing where somebody goes like, hey, I found this cool robot, it has an API, we could talk to it, we could build something with it, right? That's how it started. Before you know it, your manager finds out, tells her VP, and then you're producing 18 of these robots for a conference. And suddenly you get asked to do some knowledge transfer. If you think about these robots, HTTP API, so you can tell them how to move forward, how to move backward. We didn't specifically build the function into it, but some people figured out how to drive it off a table and destroy them in one go. It's beautiful. And of course, we're the company that built Terraform, infrastructure as code, codify everything. So of course, we codified these movement paths. Does that make sense? Of course not. Was it a lot of fun during the conference? I would say so. I think we had way too much fun till the middle of the night. And so we're doing it again this year. But we're bringing in more people, and we had to make it less complex. But the problem, of course, is robots, batteries, sensors, everything else that goes into it. There's a lot of data, even too much to just talk about right now. And so we figured, well, everyone is talking about sharing knowledge, collaborating. We're also too busy, we're also too lazy, so let's figure out how to do something with the domain knowledge that we have. I think as engineers, generally, we want to write code that's good, preferably tested. I mean, that's optional. We know that we don't always have the time for it. We want code that's maintainable. AI assistants definitely take part in those conversations. Some people say your code gets more maintainable. Some say it doesn't. That's not the point here. And in our case, I think what we wanted to have is a way to access our domain knowledge to help new people in the team and new contributors build safe code. Don't drive my $250 robot off the table, because after 9 of them, things get a little bit pricey, but your credit card company loves you for it. But there's this big, big problem. How do we access all that knowledge? I understand how a robot goes from A to B. I don't necessarily understand why I need to send LED pulses to the wheels and how that translates into meters or feet, depending on if you like freedom units or not. And this gets harder, right? The reality is not so much where can I find the knowledge, but where can I find the knowledge that I haven't memorized yet? I know that I don't know everything, and that's great. That's definitely the first step. It's admitting that you are not, the master of it all. But we got to go somewhere, and in the past this was easy. There's this company, we had to anonymize the interface to protect the innocent. They make a wiki that is great and very findable and super good for data discovery for the first 5 minutes of its lifetime. Afterwards, it gets a little bit harder, but what's also cool is every tech company that runs one of these has a librarian that does nothing but tag, make sure all the documents are found, and doesn't get paid for that. It's great. MediaWiki, we can't name the full name because we are protecting people here. But more modern companies will go the Notion route, and you'll still have the same mess. And that's okay, right? Let's go the 2023 approach. We'll just use a little text box, we'll upload a file, and then query the file or query our system with a question related to the file. This is super great. Right? At this point, if I hit the white button or the enter button, we're going to get an answer, and we're practically done. I just saved you about 20 minutes. Because we only have this one file, right? And then we add a few more for our sensors, our spec sheets, our configuration, our update logic, which didn't work the first 4 times because we uploaded the wrong files. We have some authentication mechanisms, of course, our to-do file, which we love to confuse our knowledge base with to make it think that there's features that we don't actually have. And there's a lot. This shit is overwhelming. And shit is just German for complex tasks. I was born in Austria, so I would know. But there's really the question of like, where do we go from here?
So before we move on to the solution, I just want to kind of peek underneath the hood of what Kerim just showed you with the LLM model. So at its core, this is how most AI chat apps work, right? The user sends a chat interface. This can be anything to request something from the LLM model. And then once the LLM model finishes thinking, it returns back the response, which you will see here. So if you have a specific question or a request about a specific document, like what Kerim showed you earlier, you can just literally open it up. If it's a markdown file or a text file, copy and paste the entire thing into your prompt. Or in Kerim's case, just do a hashtag and reference the document. And then that should just work. But if you do this, you run into a couple of problems really quickly. So if you copy the entire document into your prompt, you might hit the limits of your context windows, right? So if you're using OOLLaMA, if it's an open source model, the context window defaults at 4,000 tokens. Most models, the context window is about 128K tokens. This is about 50 pages of content. That sounds like a lot, but then what you're doing every single time is your entire chat window, it sends both the inputs and the outputs and then additional documents. So even though 50 pages sounds like a lot, it gets there really, really quickly. And as the closer you get to your context windows, the model gets way slower to respond, and it just isn't as accurate. So if you are using like OpenAI, or if you're using Anthropic, that's probably why after like talking to it, after 5 to 10 minutes, it's like, hey, please open up a new chat, right? Because you're reaching the limits of this context window. And then the second thing is you oftentimes don't need the entire document, especially if it's super long. For example, if I had a question about Van Gogh, I don't need to upload like a 50-page document on all the famous artists in Amsterdam. I just want the relevant section about Van Gogh himself. So that's the first problem, context length. The second one is, like Kerim mentioned, if you know exactly what document you want, and that section completely answers the question, you're perfect. But oftentimes, that's not the case, right? It might be spread across multiple documents. It might be spread across multiple sections within the same documents. So do you have enough context? Third, the document is easily copy and pastable. So like I mentioned before, if your document is just a markdown file or a text file or a JSON file, you can easily just copy the entire document, paste it in your stuff, or just reference it, and it would just magically work. But what if it's images? What if it's audio files? What if it's videos? What if it's just a scanned document that's in a PDF now? So is the information readable? Last but not least, at least in the scope for this, does your document contain sensitive data, right? One of the use cases that we had, an insurance company wanted to upload a bunch of data into their stuff, but then this included personal identifying information. We wanted to scrape that out because last thing that you want is you ask the LLM a question, and then it gives you somebody's address and credit card information. So that brings us to what did we build? The first two problems are centered around how do you get the relevant data from our documents, especially if we don't know what's inside the document itself. So RAG, I'm sure you've heard this term around all day today, or retrieval augmented generation addresses this problem. But I kind of wanted to, again, peek under the hood. How does RAG actually work? First thing you do is you collect all the documents that you want your chat app to be aware of. You use an embedding model. Give me a second. Yeah, you use an embedding model to convert all the documents into these vector representations, right? And store them into a vector database. And this is what the LLM model actually understands. The cool thing about embedding your documents using these embedding models is you get to define how big the chunks are. So like I said earlier, if you have a 50-page document on all the artists in Amsterdam, you don't need the entire 50-page document. You just need that one section. So you can specify how big your chunks are. So let's say you want to chunk your stuff by pages or by paragraphs or even by based on context. There's different chunking strategies, and you can use the one that is best fitted for you. And then the vector database will only return the paragraphs or the sections that are relevant to you instead of the entire document. So how does this work in actual real life? So when you enter in a request to the chat interface, the chat interface converts your request into a vector embedding, does a vector search against the vector DB. The vector DB returns a bunch of documents plus the similarity score and brings it back into the chat app. The chat app takes the request and all those documents, feeds that back into the LLM model, and then the LLM model gives you a response. So this is what's happening almost every single time you interact with the chat app itself. And this is a very high-level overview of what we initially did. But again, this only fixes the first two problems. The third problem is what if it's a scanned document, or what if it is a video file? And that's where Docling comes along. IBM has this really nifty open source tool called Docling, and it can parse almost any file, so PDF, Microsoft Word, PowerPoint, HTML, MP3 images, and converts them into a file that most LLMs can understand. In this case, like Markdown, HTML, doc tags, or JSON. And once you have them in Markdown, it's pretty trivial to use any embedding model to turn them into the vector database. So what you have is, for the user, nothing really has changed under the hood. This is still what they see, but then you kind of get this start of a document processor, right? So you have documents, they feed through a document processor, which the first part is just Docling, that feeds into the vector database, and everything else is the same. And then we go back into our fourth problem, which is what other sensitive data in your document. At HashiCorp, we have this cool tool called Vault. You can use Vault. It's kind of a security tool chain that does a little bit of everything. But in this case, Vault Enterprise or just Vault, you can tokenize or mask your data. So what this means is if you have credit card information in your data, you can use Vault to mask it, so it will hide away the first however many characters and only show the last 4 digits. Or you can tokenize it, right? And the cool thing about this is, let's say you want to encrypt your user's address. You can tokenize it, and then it will generate a token that you can then query back into Vault. Or if you have that token, you can just ask the LLM, hey, I have this token, find me information about the address with this token. Because every single time you tokenize it, the input should come out to be the same output. So this is a high level of what we have right now. It's super, super generic, but this is how we actually implemented it. So instead of the LLM model, we use Ollama and IBM Granite. Instead of the chat interface, we use Open Web UI. And then the cool thing about Open Web UI is it includes a lot of built-in features. So instead of shipping your own vector DB, we just use Open Web UI's knowledge database, right? So part of this, they have an embedding model. They have a built-in vector database. We thought, like for a demo, this would be just easier to showcase. And then last but not least, we have two blob storages. So when the user uploads the document into an Azure blob storage, you can put this in an AWS S3 or any other storage technology that you want. It first goes into uploads. The document processor behind the scene runs a cron job, so every 5-10 seconds, it will check to see if there's files in this uploads container. If there is, it will go through the entire pipeline where it converts it over to Markdown. From Markdown, it senses if there's any sensitive data, it masks and tokenizes it. And then after it's done, it will send it to Open Web UI in the knowledge base. So it's aware that this is available to Open Web UI. The other thing it does, just for like a nice safety net, is we also upload it into another blob storage called processed, right? So if like our knowledge base gets corrupted at any point, we have a reference point where we can just back it up from. The last thing that is like a nice touch is Open Web UI. You can create new quote unquote models or agents from knowledge bases themselves. So let's demo. Let's see if the demo actually works. So I deployed this right before this presentation, and let me see if it actually works. Cool. So on here, you will see Open Web UI. And then up here, we have a custom web app where it is like the start of our document pipeline. As you can see, there's nothing in here right now. And over here, I am in our storage browser. So in here, you'll find 4 things. You'll have the uploads container, the process container, and this is, we backed everything up in Open Web UI in another container too. So I'm going to open up uploads over here. Kerim, you said it was Pathfinders, right? That's what we called our robot. So let's create a knowledge base called Pathfinders. We'll upload the file. And I think we have one called movement plan. So let's open that up. It will process over here. And then hopefully you should see it on this side. Come on. Fingers crossed. Kerim told me not to do a live demo, so let's see if he's right. Okay, so it's not part of uploads, but the cool thing is, let's see if it's part of process. It's not part of process either. Huh.
Do you want to switch to Nomad?
What's up?
It was an upload.
Oh, it was? Oh, there you go. It's in Pathfinder, and here you'll see the document. I'm going to save the time of not downloading the file, but then I will show you what the file looks like at the end. Over here, I'm just going to go to default knowledge base. I'm also going to upload a PDF file. And then I'll create a knowledge base, another knowledge base called like sensitive data. Do not expose. And then I'll upload the 2 sensitive data. So PII and vault transform. Okay, so if I open up uploads now, hopefully I will find more files. Okay, so I see Pathfinder sensitive data, and then the PDF. It's really hard to do it from that side. So I think now we can show you what's happening in the file processor itself. So we're deploying everything on Nomad, but then if you refresh this, you can check out the logs from the containers itself. Of course, the Wi-Fi doesn't super work during the demo. But from here, you should open up file processor, view logs, and you should be able to see that it processed this document, sensitive data, do not expose. There's 3 items in it. So if I go over to storage here and then refresh, upload should be empty now. So let's hope that it's empty. It's empty, and then, wait. It's in the process of deleting the files. So I think in a minute or so, it will show up as empty. But in process, you'll find the sensitive data. Over in Open Web UI itself, if I go over to the models, you'll be able to see the different agents that are attached to the knowledge base itself. If you open up the workspace, I think the coolest one is in so workspace knowledge, default knowledge base is a PDF, and it hasn't finished processing yet. But let's try sensitive data. It processed 1 file, and nothing here. Oh, as you can see, the value of the token is secured, so it's been tokenized. And then if you hopefully refresh it, it will show the other files. It's just taking a moment. So refresh. So Kerim was right, don't do live demos during presentations.
It's working, that's a key part. You want to show the Pathfinder knowledge base?
Yeah, so
Process first.
yeah, let's wait for everything else, but then Pathfinder knowledge base. If I search for Pathfinder robots, what does bearing do in terms of movement? Send a file. This takes a while because probably the internet. If I go back into workspaces, knowledge, go under Pathfinder, you'll see that it's referencing this file. And then if you scroll down right here, you'll see bearing, and then bearing is the direction that the Pathfinder is moving on. While this loads, because this might take a while because of the internet, I think Kerim can finish up the rest of this.
Apologies for the audio effects here. I think we all love that. Let's get back to our slides, and then if you hit play again.
Does that work?
You need to mirror, I think.
Mirror.
It's so much easier to feed a knowledge base with all the data you need and tokenize everything than to get back into Keynote. But we're going to get there in a second. So there we go. I think the first question you might ask is like, well, yeah, we've got a budget to spend on this stuff. Why don't we do fine-tuning? And in our experience, it doesn't actually solve the problem in a reasonable way. Which is we want to retrieve the right information in the right time, right? Fine-tuning definitely makes sense for very specialized operations where you need super deep domain knowledge that is actually worth it. In our case, I will tell you, those robots are cool. We're having a lot of fun with it. It does not make sense to run these operations. We also don't need a specific type of answer format. We just need a useful answer that an engineer on our team can understand. That kind of accuracy really makes a difference in terms of, do you want like your colleague to basically tell you, well, this is bearing, that kind of style, or do you want the almost scientifically quotable, APA style answer? I think, anything to add to that?
I think that's good.
Then let me skip to this one. So that really brings you to a question. So, where do we take this next? We've been working on this 2 months at this point, I think, and we learned a couple of fun things. If you feed your database or your knowledge base garbage, surprisingly, the answers you get are garbage. If you have pictures that are too low res, which often happens when you buy hardware off of Amazon because it gets shipped from countries that do not always produce high quality PDFs, because you're buying from the cheapest vendor, that will have very strong effect on what you're getting. Sometimes, like ever buy tech and you get those like really thin paper printouts, the PDF doesn't look much better. So your model will have trouble understanding that. That's not a problem of Darkling. That's not a problem of any of the tech involved. It's garbage in, garbage out, right? So sometimes it's worth it to consider, is there anything I can do with my data to make it a little bit better? And of course, if you were here for the Darkling talk earlier, you've heard about the vegetative electron microscope stuff, multi-column text that gets interpreted wrongly, then gets quoted 115 times in science papers. Sometimes really it is worth it to redraw a diagram just to make sure it is well understood. And while you're in the process, don't just feed it in there, enrich it with data. You will know what those relationships are. And if you can communicate that, if you can put that into a markdown file, anything associated, everyone will benefit from that, right? Just as a junior engineer might get confused with shitty documentation, surprisingly, so does AI. And I think the biggest way we figured to work around this is to just have like a glossary.md file where we describe what each word means. To give a really good example before with bearing, when we looked at directional movement of our robots, we had bearing and angle, and they constantly confuse people and still do, I think. I'm pretty sure somebody's going to screw it up this year again, by which I mean we didn't provide enough documentation. So dictionaries don't just help humans, they help everyone. And I think when we started out, we kind of hoped that this was going to be a one-click solution. It is really more like buying a 10-foot-long IKEA wardrobe. There's a lot of assembly required. It's not a bad thing, that's a good thing. You will learn a lot, not just about the process, but also about your own documentation, and you'll know what to look for when you write future documentation. And that's really the kicker. If you produce better documentation, you make it easier for everyone, including our AI friends. All of those, lots of tools. If you don't understand them, if you feed garbage, they will lead to a subpar experience. That's not great because that leads to more hallucinations, like ingesting a to-do file that is super well described, not just fix the API, but like in a future iteration, we want the API to be fixed. If that's long form enough, your model might take that up, might understand that your API has features it does not have. These are things to keep in mind. Which brings us to two things for you to consider. Sorry for searing your retinas there. If you don't want to run something like this with Vault, check out Granite Guardian, another model from IBM that works really well for making sure you don't get low quality data or data you don't want to have into your system. Shalini gave a really good presentation at OSS Summit on Monday, I'm going to say. Slides are available. We'll also share our slides so you have all the links. And of course, if you want to try out Darkling, totally worth it. 45-minute workshop tomorrow, I think, right in this room. So come back. I hear there are stickers if you ask for it, which is worth it. For our session, if you want to try out the code, beware that we have a couple limitations in the sense that you'll need Azure right now, but we'll take PRs for S3 and everything else. Head on over to github.com/workload/pathfinder-prism. That just rolls off the tongue, so that's why we included a QR code for you. That makes it easier. It's all, of course, Apache 2.0 licensed. And with that, before we switch to the most important screen, I'll let you switch. There we go. To show you that this was a real thing, this is our answer. And
obviously I'm going to tell you it's correct, but let's see if it's actually correct. It's a little bit verbose. We probably got the colleague that just had a couple of coffees, but
It's right.
allow it to move in a specific direction, of course, yes. Essential concept in our robotic system, yes, it is. Because every time you make the robot move correctly, that's about
$250 saved. And I think that's all there is to robots. So thank you so much for your time, and have a great rest of your day.